Alright, it's time to solve some trig equations. And before we get there, I would like to quickly recap on interval notation. So when we have parentheses, that means whatever is next to the parentheses is not included in your final answer. So this would be any answer between A and B, but not including A and B. A square bracket does include it, so this would be anything that's greater than A, but it has to be less than, or it's allowed to be equal to B. When you have double brackets, that means that both of them are allowed to be included in your final answer. And if you have parentheses with infinity, that would be all real numbers, so any answer will work. Okay, so a problem with theta means that we are going to solve it in degrees. And if the problem has x, it means we're going to do radians. So let's get to it. The first problem that we have here says that we are going to solve for theta, meaning in degrees, and the answer must be between 0 and 360, which may include 0 or 360. So to do that, we're just going to start solving. So the first thing you're going to do is add the square root of 3 to both sides. That'll give you 3. Tangent of theta is equal to the square root of 3. And then you're just going to divide both sides by 3 to get tangent by itself. So the tangent of theta is equal to the square root of 3 over 3. And from there, if you remember this in your head, all you have to do is use inverse trig, but if not, you can use your calculator, making sure you're in the correct mode, and you type it in the calculator, and you're going to find out that theta is equal to 30 degrees. But you don't stop there, because you need to go all the way back to the days where we were looking at the unit circle, and you have to remember that tangent is equal to the positive square root of 3 over 3, yes, at 30 degrees, but tangent is also positive in quadrant 3, which is 30 degrees past 180, which is also 210 degrees. Now, both of those answers fall between 0 and 360, so you must answer both of them. So that is your final answer to question number 1. So I suggest you take the next example, which is very similar. Pause the video and try number 2 on your own. Go. And if you did this correctly, you should end up with 25 degrees and 265 degrees. So the first thing you had to do is divide both sides by the 2, and that'll give you the cosine of theta plus 35 is equal to 1/2. You do not subtract 35 yet because that is in the parentheses. So what you do here is find what theta is. So second cosine of 1/2 is going to give you 60 degrees. It's only going to give you the 60 degree part first. But of course, just like in the last problem, you need to find all answers between 0 and 360. So 60 degrees for cosine. Cosine is positive in quadrants 1 and 4. So if we take the reference angle of 60 degrees in quadrant 4, that's going to give us a 300 degree angle. So that's when you have that the theta plus 35 is equal to 60 and 300. Subtract 35 from both, and you are good to go with 25 and 265. All right? Next problem. Number 3. Notice how we're switching to x, so you need to be switching your mode into radians. So first thing you're going to need to do is get this equal to 0. So we're going to subtract the sine x. So we have cosine x sine x minus sine x is equal to 0. Now you can factor out a sine x. So sine x times cosine x minus 1 are both equal to 0. So just like factoring, we're going to set anything with an x equal to 0. So we have sine x is equal to 0, and we have cosine x minus 1 is equal to 0, which means cosine x is equal to 1. So we have two different answers to play with now. So sine of x is equal to 0. So when is sine equal to 0? Well, you can use your calculator, or again, think about it. We know that sine is our y value. The only time sine is 0 is when you are on the x-axis. So we have 0 and pi for sine x equals 0. But now we got to also talk about cosine. When is cosine 1? Well, cosine is going to be equal to 1 only when we have this point right here, 1 comma 0. That's when cosine is equal to 1, so only at 0. So then what are you going to do here? Our answer has to be between 0 and negative pi. It is allowed to include the negative pi. So let's think about this in terms of graphing. We can get to 0 by just staying at 0. We can also get to pi by going backwards. So this can actually turn into a negative pi because it will get us to the exact same spot. It's called a coterminal angle. All right, so the only answers that we are allowed to have are between negative pi and 0, not including the 0. So our only answer is that goes away, that goes away. The only answer is negative pi. So that is a tricky one because you have to be able to work with the origins. You also have to be able to work with coterminal angles, being able to get to pi in the negative direction, and then be able to determine which answers are acceptable and which ones are not. So that one was a little bit trickier than the ones before due to that. All right, so we have a couple more that we get to play with, and they're going to start to increase in difficulty a little bit, but I would like you to try them first. So I would like you to first try number 4. First thing you have to do is get obviously cosine by itself, and then you need to somehow get cosine squared to just turn into a single cosine. So go ahead and give this one a try. Pause it, click when you're ready. If you were slick, you came up with 4 answers. First thing you had to do is divide both sides by 4. And then to get rid of cosine squared, you need to square root both sides, which is why that became plus or minus the square root of 3 over 2. So if you think about it using the calculator, or if you think about it using the unit circle, cosine of theta is equal to 3 over 2 in quadrant 1 when it is 30 degrees. However, cosine is positive in quadrants 1 and 4, so it's also 330 degrees. And it is also allowed to be negative because when you square root both sides to solve for a variable, or in this case theta, you cannot forget your plus or minus. So cosine is negative root 3 over 2 in quadrants 2 and 3. So all 4 quadrants are allowed as long as they fit inside of our, our window. So basically, we have 30 degrees, 150. We also have 210, and we also have 330 degrees. However, our rules state that we are only allowed to go from negative 180 to positive 180. So these 2 answers down here in quadrants 3 and 4, we must use negative angles to get there. So instead of this being 330, we do negative 30. Instead of this being 210, we do negative 150. Okay, so that's it. And yes, if you want, you could say that this is plus or minus 30 and plus or minus 150. That is acceptable as well. Number 5. First thing we're going to need to do with number 5 is we're going to have to subtract the 2 cotangent to the left-hand side. So that's our first step. We have cotangent of theta, cosecant of theta, minus 2 cotangent of theta. That's equal to 0. Factor out your cotangent. So we get cotangent of theta times cosecant of theta minus 2. Again, we're going to split this. So we have cotangent of theta is equal to 2. And we have cosecant, is equal to 0. And then we have cosecant minus 2 is equal to 0. So cosecant theta is equal to 2. So again, we have 2 little things to worry about here. What we're going to do is first think about cotangent is equal to 0, which you know that cotangent is cosine over sine. So that means that's equal to 0 over 1, if you will. So where is cosine 0? Cosine is 0 when you have x is 0 at either 90 degrees, And since this is all real numbers, we know that cosine is 0 also at negative 90 degrees. So we can actually say plus or minus 90. So that's theta with our cotangent. Now we need to work with cosecant of theta is equal to 2. Well, think about cosecant. Cosecant is the reciprocal of sine, so that means where is sine? 1/2. Sine is 1/2, a positive 1/2 at 30 degrees and 150 degrees. Or we can do negative 210, but we don't need to get fancy. Okay, so there we go. So you have 4 answers here that are all real numbers. So sine of theta means theta is equal to 30 degrees. It's also equal to 150 degrees. And this negative 90 could also be written as 270. So we have all sorts of different possibilities here. So this one is a little bit tricky. So think about where our answers are. All real numbers are allowed. So that means we can write this in a couple of different ways. This answer and this answer are 180 degrees apart. So we can say that theta is equal to 90 degrees plus 180k. And this coordinate right here are 30 degrees plus 360k. And this one right here is 150 degrees plus 360k. Because it says all real numbers, there is no start, there is no stop. So anything is allowed. 390 would work. 270 would work. All of it. Just make sure you get it. Okay? So whenever you have all real numbers, make sure you add your plus whatever k. We have 2 questions left. They are a little tricky, but I would like you to pause the video and try to do this the best that you can, and then we'll talk about it again later. So for number 6, once you think about this one and you factor out your cosine, you have cosine of theta is equal to 0, and you have cosine of theta is equal to negative 1/2. Cosine is 0, again, when x is 0, so that's at 90 degrees and 270, or negative 90, which is going to end up working. And then cosine is negative 1/2 when x is negative 1/2, which is at 120 and 240. But then, since this says between negative 180 and 180, then we're going to use 90, 120, and then negative 90 and negative 120. Number 7, you just had to factor. Once you factor this out, you set each of those equal to 0, and we have sine x is equal to 1/2 and sine x is equal to 2. Well, sine is never allowed to be greater than 1, so sine x can never equal 2, so that is not possible. And sine x is equal to 1/2 when y is 1/2. So y is 1/2 when x is pi over 6 or 5 pi over 6. And because this is from 0 to 2 pi, we're going to use those 2 positive values. All right? Well, that's it for this lesson. This is Longo, and I'm out. See you, bye.